this video, I'm going to introduce the idea of Boolean logic. Boolean logic represents how a computer can control events. Essentially, what it says is, if this happens, then do something else. We can have Boolean logic which uses and or. So we can say, if this and this happens, do something. Or, if this or this happens, do something. To illustrate this point, I have a bulb which could be controlled by either of these two buttons, button A or button B. If we had an OR relationship, we could say if button A or button B was pressed, we would send a signal to the light bulb and the light bulb would turn on. Because we have the situation where we have a button A or button B, if we had button B on its own, the circuit would be complete and the bulb would turn on. If we had both of them, it's still an A or B, so the bulb would turn on. We can change that and we can actually have an AND relationship as well. To show the AND relationship, we would need A and B to be on together. If A was switched on, but B wasn't, we wouldn't get a circuit connected to the bulb. If A and B are together, we would get a circuit to the bulb and the bulb would turn on. If we just had B on its own, there'd be no circuit and the bulb wouldn't turn on. In this section, I'll explain how logic gates work. Here, I've got an OR gate between the A and B buttons and the bulb. If A or B are turned on, a circuit is created and the bulb should switch on. If both are switched on, we still have A or B, the bulb will turn on. We can replace this with an AND gate. The AND gate requires that both A and B are turned on in order to complete the circuit. If A is pressed but not B, nothing will happen. If B is pressed without A, nothing will happen. If both are pressed together, the circuit is complete and the bulb lights up. In this section, I'm going to explain truth tables. Truth tables are a way of representing how logic gates should work. In this example, with our OR gate, we're going to use ones and zeros to represent whether something is on or off. So in this case, if we have A on but B off, because it's an OR gate, our result, the R column, should have a 1 because the bulb should turn on. If A is off and B is on, we should get a result. If both are on, we should get a result. If neither A nor B are on, then we shouldn't get a result at all. Applying the same principle to the AND gate, if we have A but not B, we don't have A and B, so we can't have a result. If we have A off but B on, we don't have the AND condition satisfied, so we get nothing. If we have A and B on together, our AND result is there. And if we have neither, we don't get a result. So you can see that the truth tables are different, but represent how the logic gate works. A or B shows us that there are 3 conditions where we'll get a result, and A and B shows only 1.